In the world of AI, there's this one piece of wisdom, this role that everyone just kind of takes for granted when it comes to building a smarter AI. But today, we're diving into a new research paper that doesn't just question that role, it completely flips it on its head. For years, the mantra has been super simple. Bigger is better, right? If you want a robot to learn something new, you just drown it in data. We're talking thousands of hours of video, millions of examples. The more it sees, the smarter it gets. But what if that's not the whole story? What if just piling on more and more data isn't just inefficient? What if it's actually making things worse? Okay, so check this out. On one side, you have the big name competitors, trained on over 10,000 hours of data. But then you have this new model, SciZero, trained on just about 830 hours. So even though it's using more than 10 times less data, it just blows the competition out of the water. And that sets up a really fascinating puzzle. This is what the researchers are calling the 10x data paradox. That's the big question, isn't it? How is that even possible? Well, the answer isn't about how much data you have, but how you use it. It's about having a smarter recipe, not just throwing more ingredients in the bowl. To really understand this new recipe, we first have to talk about a core problem that has just been a massive headache in robotics for years. It's this concept called the embodiment gap. So, put simply, a robot's body is not a human body. Shocker, I know. But the way its joints bends, how fast it moves, all the different directions its parts can go, it's all fundamentally different. And this creates a huge, huge problem when you try to teach a robot just by showing it videos of a person. Look here. On the left, you've got the first-person view of a human pouring water. Simple enough. But the physical body doing that is completely different from the robot on the right. Trying to teach a robot by just showing it human stuff is kind of like trying to teach a car how to fly by showing it videos of a bird. The mechanics just do not translate. The researchers behind SciZero put it perfectly. When you just mush human and robot data together, you're basically asking one AI model to learn two completely different ways of moving at the exact same time. And, as they say, that's inherently suboptimal. It just plain doesn't work that well. So instead of trying to force one model to learn two different things, the SciZero team came up with this really elegant two-stage solution, a much smarter training recipe. And here's how it works. In step one, the main AI brain just watches about 829 hours of human videos. Now, it's not learning how to move its own robot body yet, it's just learning the general concept of a task. What does picking up a cup even mean? Then, in step two, a separate specialist part called the action expert takes over. It uses a tiny data set, just 30 hours of actual robot data, to learn the specific physics and mechanics of its own body. This diagram really shows us how that separation works. Over on the far left, the AI is watching the human actions, and it's pulling out the general ideas. That knowledge then gets passed along. But now, follow the arrow to the right. Here, this specialized action expert, you see it there in orange, gets trained on a very small amount of actual robot data. This is the whole game. It completely decouples the general world knowledge from the very specific embodied skill needed to get the job done. So, the theory is solid, but does this smarter recipe actually work when the robot has to face the real world? Well, the team put SciZero through a seriously brutal gauntlet of complex, real-world tasks. And the results were just staggering. SciZero, which you see here in the tall pink bars, had an overall success rate more than 40% higher than the next best model. Look at this chart. Across almost every single task, it just completely leaves the others in the dust. And it wasn't just good at one thing. This radar chart shows just how versatile it is. SciZero was amazing across a whole range of skills, from really delicate finger movements like grasping and pulling to big whole-body movements like walking and squatting. It's a true all-rounder. So, what does this all mean for the future of robotics? Well, this isn't just another small improvement. This really represents a fundamental shift in how we think about training. Let's just break down the key takeaways. First, this proves that for training robots, it is all about quality over quantity. The right data is so much more important than just more data. Second, the secret sauce really is this two-stage process. Learn the concept first, then learn the specific physical skill. And finally, this new philosophy could be the exact breakthrough we need to massively accelerate the creation of humanoid robots that can actually work in our world. It moves us so much closer to a future that looks a little something like this. Not just robots in a lab,
but robots that can actually understand human tasks and do them in human environments, with a level of skill we've really only dreamed about until now.
And that leaves us with one last, pretty provocative thoughts. For decades, we've thought the biggest thing holding back capable robots was just collecting enough data, which is an incredibly expensive and slow process. But if the real key is a smarter training recipe, one that uses less data more effectively, well, it makes you wonder, doesn't it? How much faster will that future actually get here?